Okay, so now we're continuing on in grade 8 math. This is chapter 1.5 on scientific notation. As you notice, the word scientific notation has the word science in it, and so this notation means it's a way of writing numbers that's often used in science to represent really big numbers or really small numbers. An example of a really big number might be, for example, the number of bacteria that you find in a colony. Also, might be the distance from the Earth to the Sun. Also, you can use scientific notation to represent really small numbers to avoid a lot of decimal places. And an example of this might be the diameter of a cell or even the wavelength of light that you can measure. So the way that we look at scientific notation is all based on powers of 10. So which means 10 to the something power. The reason why we use 10 is that 10 is a very easy number to use in our decimal system because we just have to move the decimal over one place on either direction to represent the next level. And I think we learned this in grade 6 when you looked at kilo and centi and you looked at deca. Those kinds of prefixes represented every power of 10. So if we look at the original one, which is just the unit, is called 10 to the 0 power. So that's just the regular number. And then something that is 10 times larger is 10 to the 1. And this is called the 10, obviously. The next one above that is 10 times 10, which is 10 squared, which is 100. Then if we continue on, if we use 10 to the third power, which is 10 times 10 times 10, or 1 with 3 zeros, this is 1,000. And you can continue on if you look at 10 to the fourth, 10 to the fifth, 10 to the sixth. They have each special names. So the 10 to the fourth would be 10,000, 10 to the fifth would be 100,000, and 10 to the sixth would be 1 million. If we work backwards and we look 10 to that negative 1, it's representing smaller numbers. So this is a tenth, and a 10 to the negative 2 would be, or negative second, would be a hundredth. So if you can notice, they're actually paired up with their partners on the other side. So 1/10 of something is the opposite of 1/10 of something, whereas 100 somethings is opposite of 100th of somethings. And so we could take a look at how we can represent a number based on just this power of 10. So if we take the number 480, for example, if we want to break this up into scientific notation, what we want to do is we look at the largest place value of the power of 10. And this is this number 4. Well, this 4 is not really a 4, but it's truly a 400 or a 400. Now we do have this 80 in there, and 80 is just smaller than 100. So really what this is 400 plus 0.8 of 100. So if we combine those together, 100, the power of 10 is 10 to the 2. 10 to the second is 100 if we looked over here. Now, the whole number part of it is what's left over. So we have 4 and 8/10 of that 100 creates the number part of it. So this is now called scientific notation, is because we took the number 480 and we brought it down to one digit. So this is what's special about scientific notation is there one digit and then a decimal place. And then we have times, then the power of 10. So let's take another example. If we take 1,048, if you look at which power of 10 we are in, we look at the largest number, and that's the 1. And this is 1,000. And 1,000 is 10 to the third power. So we take 10 to the third power will be our power of 10. And now we have to look at the rest of the numbers, and all we simply need to do is move the decimal place 3 times over because it's 1,000 to make this now one whole number, and the rest of the numbers just fall into place. So 1,048 is the same thing as 1.048 times 10 to the third power. If you're not sure about that, what you could do is just type in your calculator 1.048 times 10 exponent 3, then you'll get 1,048. So that's scientific notation. If we wanted to work backwards, let's say if I give you the example 8.01 times 10 to the fourth power, and I said convert this into standard notation, which is just the number of it, well then we look at this, and 10 to the fourth, if we look at our chart, is 10,000. So if we convert back to standard, we see that this is 8 10,000s, or really 8 10,000s is 80,000. So we have 80,000 something. We see the next digit is a 0, and then the next digit is a 1. But we need to make it 10,000, so 80,000. So this is the 80, and now we have to complete the rest of our zeros, and I'll put the decimal point back there to show that it's 80,100 is the actual answer. To go back and check, we can look at the number of decimal places and go 1, 2, 3, 4, and that will be the power of 10 that is represented in the scientific notation. There's a bunch of examples in the textbook that you can look at, but let's just review what we looked at. A scientific notation involves two things. It involves a power of 10. So you need to have times 10 to the something power. The other thing that you need to have is only one digit and decimal point and all of the other digits following that number. So those are the two components of scientific notation. I hope you understood the lesson.